Hello everyone, welcome to the HTML5 client update. This is Summit 8 and we're joining from Ottawa, Canada. My name is Anton Georgiev. I work for Blindside Networks in Ottawa. Behind me are...
I'm Daniel Perone. I work for Blindside Networks.
My name is Maxim Klopostov. I've been working on the BigBlueButton for the last few years as a Seneca College student.
I'm Valdo Cauã. I work for IMDT and I'm working with BigBlueButton for the last year. Sorry.
I'm Gabriel. I work for IMDT and I have been working with BigBlueButton since November last year.
I'm Alex. I've been working at BigBlueButton project for Seneca Center of Development for Development of Open Technology.
Thank you for joining us today.
You forgot me. Hey, I'm Lucas. I'm from Porto Alegre, Brazil. I work with the MConf team. I've been working with BigBlueButton for 3 years now. That's it.
Thank you for joining us. Let's first go through the agenda for the HTML5 client. The release of the product is going to proceed in several stages, and in the first one we're focusing on a viewer client. So what we want from the HTML5 client is to support two-way audio and chat, to be able to view desktop sharing, and of course to be able to view the presentation. This is the slides and all the annotation the presenter writes and draws on the slide. And also an extra feature we decided to add is to be able to advance slides as a presenter. Of course, this means that the HTML5 client user will not be uploading his own files, but will be able to move forward and backward on the slides that the presenter uploaded. So far in phase 1, we have completed two-way audio. This is WebRTC audio, and of course, two-way chat. You can do public and private chat. Also, you can view the presentation with all the slides, the whiteboard annotation, and you already can advance slides as a presenter if you've been assigned as a presenter. We have several items that are yet to be completed. One of them is viewing of desktop sharing. We'll talk about this later throughout the presentation. Another is switching the user interface to React. This is going to be a very big task, but we have already started. Also, you probably watched the 2 o'clock presentation on the new design. It was presented by Tyler. We are also going to adopt that design as part of phase 1. Let's go through the architecture of the client. The architecture hasn't changed since our last update in November 2015. So for this stage, the presenter is going to be typically a Flash client. And let's go through a possible event. So let's say a Flash client presenter uploads a new slide. This will reflect in the BigBlueButton server, and using Redis messages, this will be also displayed on the HTML5 client. So for the HTML5 client, we use Meteor, and we have 2 different components in it, HTML5 server side and client side, and they are connected with database MongoDB, which on the client side is MiniMongo. The best thing that Meteor provides us on the HTML5 client is this connection between MiniMongo and Mongo. So whatever we push in the database on the server side can be available on the client side automatically. This also allows us to filter what kind of information will be available on each of the clients which is served by the same server. And as I said, the architecture is multiple clients using exactly the same server and database. So if a Flash client user sends a chat message, that will go to BigBlueButton core, and through Redis it will be propagated to the HTML5 server, and from there everybody who's in that particular meeting will receive the message on the client.
And let me go through a short introduction of the current technology stack that we're using in HTML5 client. First of all, ever since we started working on this implementation of the client, we've been using the framework called Meteor, which is basically a wrapper around Node.js, so a Node.js-based framework that provides a lot of functionality on the background and basically makes the development of Node.js applications much easier for us. So one of the big things, as Anton mentioned before, that Meteor provides us with is this mini Mongo, which is basically a client-side in-memory implementation of MongoDB APIs. So that as a result, we have collections on both server side and client side with the same names and configuration, and they are actually different, but Meteor provides us with the functionality of automatically syncing those collections on the background, so that we have the ability of kind of accessing the same collection on the client side as well. Another thing is that, as I mentioned before, it's based on Node.js. So as a result, it's like JavaScript all over the place. And of course, since it's Node.js based, it's all asynchronous and have many features to Node.js as well. One big thing that Meteor provides us with as well is this reactive approach for the data on the client side, so that it's available for us to operate, and it's reactive. So as a result, we don't really need to care about synchronizing the client side and server side. Meteor does it for us. And one of the things that we have been working on for the last few months is the transition to the new framework called React. It's still in progress, but it's a big step in the evolution of our design on the client side, basically. I just want to mention a few things, a few big changes to this stack of technologies that's our client has been going through for the last few months. So first of all, we've been using CoffeeScript ever since we started working on that client, but with the release of the latest version of JavaScript, ECMAScript 2015, we just decided to switch to that, so that right now all the code on the client is JavaScript. And one thing is, as I mentioned before, is React. So we are transitioning from the template engine that we used before. It's called Blazed, which is like a Meteor implementation of the template engine, to the React, which gives us a lot of benefits, and we're trying to keep up with the trends in the Meteor community as well. So transition to the Meteor means quite a few things, and quite a few changes to the stack and to the usage of other tools as well. One of those things is that we can't really use Raphael.js anymore for the whiteboard. It's the SVG library that we used for drawing the shapes and the images on the whiteboard. And due to the changes, due to the switch to the React, we can't really access the actual DOM anymore. So we are trying to switch from Raphael.js as well as a result. Since we're doing quite a few changes to the whole architecture of the client side right now, due to this switch to React, we also decided to decide. We're trying to decide on some kind of a code guideline that we created within the last months, and you can actually see it on the whiteboard right now. You can see the link to it. So it's a Google Docs document that basically provides the guidelines and the patterns and guides that we're going to follow we are following right now, and we're going to follow through this transition to React in the future as well. So that's pretty much it on the overview of the stack.
So, as Maxine said before, we're transitioning the client side of the application to use React.js. React is a templating engine created by Facebook, and it will provide us with the means to better modularize the application and separate each part of the user interface as something we call a component. And by migrating to it, we hope that it will become easier for us to develop it, for third parties to extend it. And yeah, we're going to show you a few examples of what we mean. So
with the transition to React, we are changing a bit our folder structure. So on the picture, you can see that now we have a components folder where every component has his own code, so it's encapsulated and more modular. And with the React transition, we are switching from Ion router from Meteor, and we are implementing the React router. So I think that's it. And
so actually, this is a picture of the current HTML5 interface, which you can access through the demo server. And in this, each part of the interface, like for example, this is called the user list. This is called the whiteboard and the presentation. This is the public chat. And each one of these parts has its own folder, its own style sheet. So if you want to modify the look of just one part of the application, you know just where to look and where to modify it. And in the future, every little part of the application will be its own component. We have components for commands, emojis, stuff like that. And we have to talk about the
structure.
Yeah, the structure.
So talking a little bit about the structure of those components, we decided to separate them in some smaller files. So we have each component has a service that fetches the data and maps only the necessary data for the component to work. After the service, the service sends the data to the container, which is a React standard having a container for the component. The container then calls the component, and the component itself has a style sheet attached to it by CSS modules. So that's pretty much the file structure for our components.
So by having a service fetch the data from the server, we can be server agnostic, because if the data changes, the message change on the BigBlueButton side, or if we even decide to switch from Meteor or something like this, we just need to change the service, the way the service fetches the messages. But all the components are expecting the data to be present, so we can encapsulate the code better this way. Yeah.
So listen only, we are supporting a two-way audio in the client, and we have listen only audio, which is WebRTC audio. And this does not require the client to share any peripherals. The client can just join the audio, and it was originally using SIP.js, and the new technology using VIII and FreeSwitch is what we'll be adding as an option. And so one of the last remaining viewer capabilities of the HTML5 client was viewing the desktop sharing. So we are implementing WebRTC web real-time communication. It's all implemented through the browser APIs. It is browser-browser and peer-to-peer communication. We use Modverto, which connects to FreeSwitch, and it uses HTTPS and secure communication. And this communication is all done in the browser, just using JavaScript to connect directly to FreeSwitch. So more about Modverto, which is what's making this communication possible, is a FreeSwitch endpoint, and it implements a JSON calling and messaging connection that we can use over secure WebSockets. So what this means is we can just use JSON messages and objects and securely communicate with the FreeSwitch server just with JavaScript on the web page. The WebRTC calls originate from the HTML5 client, and they communicate directly with FreeSwitch, and this allows for sharing of all browser-supported media. Screen sharing and audio and video are all sent over WebRTC, and so we can receive and possibly send all those different types of media. WebRTC Desk Share has been developed for a few months now and have prototypes, and we're just waiting for FreeSwitch and other technologies that we use to get more mature and more stable before we can look to really implement them.
Also, we added log settings. Now a moderator can log viewers' public chat, private chat, and audio. The only thing we don't have log settings for is layout, but we don't have layouts in HTML5 yet, so probably will. Yeah. Also, we added poll from viewers' perspective recently. HTML5 users can vote, and if presenter decides to publish a poll, you'll see a whiteboard mark on the whiteboard. Here you can see the link to our GitHub repository with all the source code. Just keep in mind that our master branch is still in development. There's a lot of changes, and you probably won't make it work. So if you want to try to build on top, just follow the documentation. And if you want to see how it looks, how our latest stable version of BigBlueButton looks like, you can go to demo server, and all the source code for the demo server is on 1.0 release branch. Are there any questions?
We have several minutes for questions and answers. Please write your questions in the public chat, and we'll be happy to answer them. We have a question from Oliver about webcams and how they're going to be supported. So for the first stage of the client, of course, we already said that we are looking mostly into desktop sharing, the view of a desktop sharing stream. And the way we are prototyping this, the way we've developed it so far, is taking advantage of FreeSwitch and Modverto. The default for that approach is that on FreeSwitch, all the incoming streams will be mixed together. So the HTML5 client will be viewing one mixed stream from FreeSwitch, and we can split that on the user interface of the client. So this will all be, the way we think it for now is that all of this will be one stream, and it will be split once it arrives at the client. Oliver is asking about some specifics on the type of connection. So again, one of the use cases for HTML5 client is for mobile devices, and for handheld devices, typically you can expect a connection that's not as good as a desktop that's connected on wired internet. So one of the disadvantages, one of the challenges for viewing streams on this kind of client is that the device won't have enough bandwidth to be able to view all the streams. For now, we are only thinking about desktop sharing, but and again, this is one stream, so we don't have a way at this moment to limit what stream will be sent to the client, because we're only looking at one stream. Of course, we can change the resolution of the stream. So for mobile phone users, we can send a lower stream with lower quality, so it's not as big of a challenge for the device to display.
Also, on a mobile device which may have a more unstable internet connection, using Modverto to connect to FreeSwitch, FreeSwitch will keep track of all the sessions and connections. So if the viewer drops connection, loses internet connection, the video stream will reconnect automatically.
Mr. Fred Dixon asked when it will be delivered. And we all know this answer the way Fred answers it himself. It's not a real question to answer now. Please write down all questions you have in the chat. We have a few more minutes. And again, this session will be recorded, so you can see it again at a later point. The link to the recording will be posted on the Google form. So the next question from Oliver is if the HTML5 client updates will be available for 1.0. No, the HTML5 client is moving along with master, and we are looking into supporting everything that will be supported in 1.1. So if you want the HTML5 client that's on master, you also have to be using the master version of BigBlueButton core.
Yeah, we're good.
Thank you for joining us for this session.
They're laughing at you downstairs.
We'll keep you posted, and please check the master branch and, of course, the HTML5 client overview. You can try the client on them. Thank you again.